So we are going to talk briefly about exponents today, and this is a formal rule. This rule is called the product of powers property. You have been using this rule for a long time, probably since you have learned exponents. You just don't know you're actually using the rule. So I'm actually going to start here with example 1, and then we're going to go back to that rule and we're going to talk about that rule. But example 1, I'm going to write it over here off to the side like I usually do. We're going to start with A. So A, we have 4 to the 7th power times 4 to the 11th power. Well, let me just color code a bit. 4 to the 7th times 4 to the 11th. Now, what do we know about exponents? What does 4 to the 7th mean? Or what does 4 to the 11th mean? Why would we choose to use an exponent over the other thing that it actually is representing? What do exponents do? Anyone? I can't really see your hands. No one remembers what exponents do. Exponents condense repeated multiplication. So if I wanted to write 4 to the 7th power in expanded form, what would that look like? What would 4 to the 7th power in expanded form look like? So if 4 to the 7th power is the condensed form of repeated multiplication, that means in expanded form it would look like this. 4 times 4 times 4 times 4 times 4 times 4 times 4. That's 4 to the 7th power in expanded form. Now we're multiplying 4 to the 7th power times 4 to the 11th power. 4 to the 11th power can also be written in expanded form. What does 4 to the 11th power look like in expanded form? Four to the 11th power would be 4 multiplied by itself 11 times. Okay, so the condensed form, or the exponential form, is 4 to the 7th times 4 to the 11th. In expanded form, we have 4 times 4 times 4 times 4 times 4 times 4 times 4. I'm not going to keep repeating all the 4s that are being multiplied, but this, all of these 4s would be your answer. So in exponential form, what would the solution, what would the answer be to 4 to the 7th times 4 to the 11th?
Are you going to say answer what 4 to the 7th power would be?
No, I want you to tell me what 4 to the 7th times 4 to the 11th would be in exponential form. So it's all of these 4s. What's the exponential form to represent this?
Miss Bela, I can't hear you. You're breaking up.
Can you hear me now?
Yes.
Okay. So to figure out the solution in exponential form, all you have to do is count all these 4s. How many 4s are there? There are 18 4s. So if there are 18 4s, what would that look like in exponential form? If 4 to the 7th power is 4 times itself 7 times, and 4 to the 11th power is 4 times itself 11 times, what does 4 multiplied 18 times look like in exponential form?
Would it be 18, right? Times 18. No, times 18 times 18.
Nope, we're still working with 4. There are 18 4s. So that means 4 is still your base number.
It would be 4 times 18.
Yes. 4 to the 18th power is your final answer. So this is exponential form. This is expanded form. And this is the solution in exponential form. Whoa. Is someone like falling? Zion, are you okay?
Yes, I was looking for it.
Okay. Okay. All right. So now let's relate this to the rule. So now we have this rule. Using algebra, when you write something using algebra, it's all variables. It's a literal equation to show you the relationship. So we have a to the m power times a to the n power. We have two exponents with the same base. And then the solution is a to the m power plus n power. So if that's the rule, how do you think we find the answer to 4 to the 3rd times 4 to the 2nd? We have two exponents with the same base, but different powers. What do you think we're going to do here to find the answer? They have the same base, so we're using 4, that same base. How do you think we're going to find the answer to this without writing out all of that long multiplication? We can say A now equals 4 and M equals 3. A still equals 4 and N equals 2. So based on what happened here, how do we find the solution? In the first example, we added the powers together. So we're keeping the same base, we're just adding the powers together. So we have 4 to the 3 plus 2 power. What's 3 plus 2?
5.
Thank you. So we would have 4 to the 5th power. So if that's the case, and that's the rule, numbers with the same base and different exponents, how could we find 4 to the 18th power in a more simplified way? I could solve 4 to the 7th times 4 to the 11th without writing 4 times 4 times 4 times 4 18 times. How am I going to do that? Well, first I'm going to make sure that my exponents have the same base, and they do. The base is 4. And since they have the same base, now I can add the exponents together. So it becomes 4 to the 7th plus 11th power. What is 7 plus 11? Seven plus 11 is 18. Thank you. So 4 to the 7th plus 11th power would be 4 to the 18th power, which is the same solution we got when we wrote this all out in expanded form. So this is the shortcut way. You can do it in exponential form if it has the same base. So this is just part 1 of these notes. There is going to be a second part, and that involves variables with coefficients.